Okay, exam 1, fall 18. What is the width of your pinky? Your pinky is about 1 centimeter in width, and then a centimeter is 10 millimeters, but I can do the conversion here. So in 1 meter there are 100 centimeters, and then in 1 meter there are 1,000 millimeters. And so I lose that, and I get 1 centimeter is equal to 10 millimeters. A millimeter is about the width of a penny, so about 10 of those will give you across the width of your pinky. The slice of bread is about 10 by 10 centimeters, so about 10 pinky widths across, to about 10 across like that. And so 10 times 10 is 100 square centimeters. Which of these equations is dimensionally correct? Well, the first one is, right, we recognize that as one of our kinematics equations. Let's just write it out though. Meters per second plus meters per second squared times seconds. That cancels out, and I'm left with meters per second on all three. So that one's okay. How about this second one? This one looks a little more complicated. The masses, which are in kilograms, cancel out. One of these velocities cancels out, and that becomes v squared. And then one of these x's cancels out, and that just becomes x. So I'm left with a equals v squared over x. So that's meters per second squared equals meters squared per second squared, and 1 over meters. And then my meters cancels out. So that one looks okay. Let's look at this one. M's cancel out. Those are kilograms. And the half is not relevant because it has no units. So this is meters per second equals meters per second squared times 1 over meters. And that cancels out. Yeah, that doesn't work. Meters per second, 1 over second squared. So the answer is B. How many significant figures should the solution to this expression have? Well, we can do the actual math if you want. So 15.1 divided by 6.0, that's going to be 5.213 minus, keeping 2 sig figs, 2.5. And that's equal to 2.7. Oops, I lost my pen there. 2.7. So it has 2 sig figs. I didn't really need to do the math. I know that this is going to have 2 significant figures. And I also know that it's going to be around 2 or 3, right? Because it's 15 divided by 6 is about 2 point something. So I know it's going to just have 1 decimal place. 2 significant figures and 1 decimal place. And since I only have 1 decimal place here, I'll have 1 decimal place here, or 3 here. I keep 1 decimal place in the final answer. And that's going to then have 2 significant figures. All right, what is this angle theta? Look, I have the opposite side and the hypotenuse. So SOHCAHTOA, that's a sine. So the sine of theta is equal to opposite over hypotenuse, 6 over 6.7. So I do the inverse sine of 6 over 6.7. I get 63.5 degrees, 64 degrees is the answer. And then also, what is x? So I know that x squared plus 6 squared equals 6.7 squared. That's from the Pythagorean theorem. And then solving that, I get 2.98 or 3. So the answer is 3 meters. We're just looking at this, we could have gotten rid of some answers. Let's just think about how we could have done that. So I have a 6.7, and I know this is 64. I want to know what is x. Well, I know that x, because this angle is so big, I know that this one is, what's this, 26 degrees. I know that x has to be less than 6. So I can get rid of this, I can get rid of this. So I'm left with A, C, or E. And we don't have any good way to really discern between those three. We just need to do the Pythagorean theorem. Let's look at number 7. All right, give the number of significant figures for these numbers. I have 1 sig fig. Here, all of them are significant So that's 1, 2, that's 6. Here I only have 1. Here I have 5. Notice that the 0 is significant. It is not a placeholder. And then I have 4. So 1, 6, 1, 5, 4. Whoop. That looks like D is the answer for number 7. Which of these is standard measurement for the meter? It's the distance that light travels. Based on the... Okay, this is a good conversion problem. So I have 75 times per minute. That's the heartbeat. Each beat, it moves about 70 milliliters of blood, and I want to express this rate in cubic meters per second. So the first thing I need to figure out is how many cubic centimeters per second. And I give you this hint that 1 milliliter is equal to 1 cubic centimeter. It's a cc. So I say 75 times 70. That gives me the flow rate in milliliters per minute. Right, if it beats 75 times per minute, and each time is 70 milliliters, then I just multiply the two to get the number of milliliters per minute. Now let's do the minutes. So I know that 1 minute is 60 seconds. And now let's do the milliliters. I know that 1 milliliter is 1 cubic centimeter. I need to convert that to cubic meters. I know there are 100 centimeters in 1 meter, but don't forget I gotta cube this, and when I do all that I get, let's see, 75 times 70 divided by 60 divided by 100 cubed. You get 8.8 times 10 to the minus 5. We know it's got to be pretty small actually, right? Because a cubic meter of blood is a lot of blood, and so it's not pushing that much blood through it. So we could have probably reasoned that it was either C or D. We could certainly say it's not E. Like, you don't even have 530 cubic meters of blood in your body. You probably don't even have 0.88 cubic meters. I don't know. I'm pretty sure you do not. But yeah, so we need to do that unit conversion to find out the answer. Commuter backs out of her garage with an acceleration of 3 meters per second squared. How long does it take her to reach a speed of 4 meters per second? So V is 4.00 meters per second, and her V naught is equal to 0 because she's backing out of her garage. She starts at rest. So that's meters per second, and I just want to know the time. I need to recognize here that the acceleration is positive and the velocity is positive. They're both in the same direction. She's speeding up, right? So I say V is equal to V naught plus AT. 4 is equal to 0 plus 3.0 times T. And so T is equal to 4 divided by 3. That's 1.3 seconds. If she then brakes to a stop in 0.7 seconds, what is the magnitude of her deceleration? Now, here my time is 0.700 seconds. That's how long it takes to stop. And here her V naught is not 0. It's going to be 4.00 meters per second. And I want to know what is her acceleration, and her final velocity is equal to 0. So a very similar problem. V is equal to V naught plus AT, but your final and initial velocities got flip-flopped. What was 0 and what wasn't? And I like that problem for this reason. 0 is equal to 4.00 plus A times 0.7. So A is negative 4. So which should be 4 over 0.7, should be 5.7, let's just double check. Yeah, 5.7, and yeah, it looks like I should have kept 3 sig figs there. Sorry, this actually be 5.71 meters per second squared. Notice it's negative. The velocity and acceleration are in opposite directions, so she is slowing down. I considered commuter in the previous 2 problems while stopping in 0.7 seconds. What distance does she cover? So I want to know what is x. This is my equation for x, so I have to use this in some way. So let's just write it down. Do I know V naught? Yeah, I know V naught. It was 4 meters per second. And it takes her 0.7 seconds to stop, plus 1/2. And now I need to be careful because I need to keep that negative 5.71 for my acceleration. And then 0.7 squared. All right, so let's see, 4 times 0.7, oh, that's 2.8 minus, I get minus 1.4 equals to 1.4. So D is the right answer. You got to be careful because if you had this acceleration here as positive, you would have gotten B. Oops, excuse me there. Lenovo. Sorry. All right. So you have to be careful because if you got your acceleration the wrong sign, then it'll mess it up. You'll get the wrong answer. But the answer for number 12 is D. All right, number 13, you throw a ball up with an initial speed of 60 meters per second. How high does it travel? First of all, how long does it take? Well, I think if you've been listening, you know that it takes 6 seconds to go up. But let's see. So let's draw a picture first. It goes up, comes back down again. I know that the velocity at the top is equal to 0 meters per second. And I know that the velocity down here is equal to 60 meters per second. So I say V is equal to V naught plus AT, and then that's 0 equals 60 minus 10 times T, so T is equal to 6 seconds. That's how long it takes to get from here up to here. So the entire time would be 12 seconds, right? That it takes 6 seconds to go up and 6 seconds to come back down again. But really, I'm looking for how high does it travel. Ah, shoot, sorry. So I'm looking for what is Y. V naught T plus 1/2 AT squared. That's going to be V naught is 60 times 6 minus 5 times 6 squared. That's 3,600, excuse me, 360 minus 180. So 13 should be A. And 14, what are the displacement and distance traveled by a police officer who walks 4 blocks north and 2 blocks south, 4 blocks north again, and finally 12 blocks south? I like the easiest way to do the displacement here is to give them signs. So you can draw a picture too, but I like just giving them signs. Sorry, I'll come back to this just a second. So I give them signs. That would be plus 4 north, minus 2 south, plus 4 north, minus 12, that's south. And then I add these up. That's plus 8, minus 14, minus 6. So my displacement is minus 6 blocks. Oh goodness, look, that gives me the right answer. And then if I want to know the distance, I just add the numbers up. So I forget the signs, and I have 6, 10, 22 blocks. So C is the right answer for number 14. And now 15 is for a couple of questions. What is the object's acceleration at t equal 1 second? I'm looking for the acceleration at this point, which is the slope of this line. So there's my run, there's my rise. My rise is 3, my run is 2. Rise over run is 3 over 2, or 1.5 meters per second squared. And then what is the distance that the object travels between 0 and 4 seconds? Let's see, I'll do this in a different color. So I'm looking for the area of this and of this. So of this block, it's space time 2 to 4 is 2, times 3, so this is 6 meters. And here I have 2, and I already know this is 3, so that's 6, but it's actually half of that, 1/2 base times height for a triangle. So 3, so the distance or the displacement is 6 plus 3 or 9 meters, that's 16. And then this is a similar question, but notice this is a position versus time graph. And I'm looking for a couple things, several questions about this graph. What is the object's velocity at t equals 3 seconds? That's right there. And so to find that, I'm going to draw a line that best fits that data. It'll look something like that. You might have drawn a slightly different line, but you would have gotten an answer that's very close to the one that I put. And then I have rise over run. The rise goes from 10 to 45, so that's 35, and then the run goes from 2 to 4, so that's 2. That's 35 over 2 is going to be 18 meters per second. So number 17 is A. Number 18, what distance has the object traveled at t equal 1.4 seconds? T equal 1.4 seconds is right there. Hold on, I need to pause. My pen's not working. Just a Okay, sorry about that. I had a problem with my pen. So anyway, we're saying that the distance traveled at 1.4 seconds. That's right there. Now, you might be inclined to take the area to estimate the area, and that would be incorrect. But what you want to do, we did this similarly in a OpenStax problem, is to say, well, I go from 0 to 20 meters right here. So from there to there, he travels about 20 meters, and then he goes from 20 down to about 10 meters right there. So he travels an additional 10 meters. And so the distance that he travels is 20 plus 10. That's going to be 30 meters. Now, some possible pitfalls is that if you're kind of savvy, actually, you might get confused and say, well, I'm looking for, what if I look for the displacement? The displacement would be different, right? Because I'd be going 0 to 20 and then back to 10. My displacement would actually be just 10 meters. But the answer is 30 because I'm looking for the distance. And again, that was like an OpenStax question that we had. All right, which of these statements is true? Is the object slowing down between A and B? Notice the slope here is big, slope here is really small. So yeah, that's true. Is the object not moving at point C? Right here, the slope is 0, not moving. That's true. The object has a constant velocity at point D. Yeah, pretty much. That's pretty much a straight line at point D. So the velocity is not changing, it's constant. And it's moving in the negative direction at F. Is it moving in the negative direction? Well, it has a negative velocity. It has a negative slope. So a negative velocity, that means it's moving in the negative direction. So every single one of these statements is correct. E is the right answer for number 19. All right, consider the motion of this particle. What is the sign of the acceleration? Okay, well, first we need to ask ourselves, what is the sign of the velocity? It has a negative velocity. And is the velocity increasing or decreasing, or is the speed increasing? It has an increasing speed. Because it has an increasing speed, the acceleration must be in the same direction as the velocity. So it has a negative acceleration. So C is number 20. Which of these quantities has a direction? Speed does not, it's a scalar. Velocity does, acceleration does, time does not. So 2 and 3, D is number 21. When throwing a ball straight up, which of the following is true about its velocity and acceleration? All right, this was from our concept test. The velocity equals 0, but the acceleration is not. We should calculate the sum of these vectors, and then what is the magnitude of them? Okay, so let's do it like this. I have my x components and my y components of A, B, and C. I'll do a little table. My x component of A is 3, y component is 0. The x component of B is 0, the y component is negative 2, notice on the negative y-axis, and C is negative 5 and 0. And then I do the sum of all these, so my sum of that is negative 2, the sum of this is negative 2, and I want to know the magnitude of that. So if I were to draw this, it would be a vector right over here, that it'd be 2 and 2, and then the square root of 2 plus, the square root of 2 plus 2, the square root of 2 squared plus 2 squared is the square root of 8, and that's 2.8 units. Okay, so that was adding 3 vectors that were all on axis, but here's a problem where you have to add them where they're not on axis. And we need to go through our steps. What is AX? What is AY? AX is 3 cosine of 30. AY is 3 sine of 30. That's going to be 2.6. And then this is going to be 1.5. And then what is bx and what is by? Bx is negative 4. By is equal to 0. Now I find what is rx. If r is equal to a plus b, what is rx? It's going to be ax plus bx. That's 2.6 minus 4. And then ry is ay plus by, which is 1.5 plus 0. And so I have an rx of minus 1.4 and an ry of 1.5. Look, I can look at this and tell pretty much that it's going to be close to 45 degrees. But let's draw a picture because you'll begin to see what the answer is without really going any further. Rx is minus 1.4 and Ry is 1.5. So I know that my vector lies over here. And notice that all these vectors are measured from the positive x-axis. So I need to know this angle. I'm going to call this angle phi. Now, let's go ahead and find out what is this angle. Now, theta is the inverse tan of opposite over adjacent. That's 1.5 over 1.4. Which is 4.7. Excuse me, not 4.7, 47 degrees. So I know that that angle is 47 degrees, so phi is going to equal to 180 minus 47, which is 133 degrees. So B is the right answer. But look, every single one of these is in the first quadrant. But I know that my answer is in the second quadrant, so it has to be B. That just sort of a little pat on the back to me since I see that. All right, vector A lies in the xy plane at what angle? Does it have a negative x and a positive y? So negative x would be right over here, positive y would be here. What angle can this possibly be? Well, it's somewhere between 90 and 180. So it can't be that, or that. It has to be that. What is the vector A minus B? Remember, we're going to take this B and we're going to flip it around the other direction. So A and then minus B, and then this is my resultant. So it's going to be the vector that looks like that. That is C for number 26. For what angle is it possible that the x and y components are equal? Only with an equilateral right triangle. That's 45 degrees. None of those others give you equal x and y components. Let's see, who is my favorite student? Well, Fred Weena. Actually, I've never had a student named Fred Weena, but I feel like we're ripe to have a student named Fred Weena. I never had an Essie either, but I love all my students. Y'all are awesome. I hope that this test went okay for you. If not, of course, come see me. We can talk about it.